चलो, कैम्स ऑन एवरीवन। So last class we did with the wind problems. So great. So today we will start off with projectile on incline. Okay. No. So let's say we have an incline like this. This angle is alpha, and you're projecting with speed u at an angle theta. So this thing goes and lands somewhere here. So this is what we take as range here. So this distance is counted as range. So here theta is the angle of projection. Your alpha is the angle of inclination. So how do we approach this problem? So what we do here, remember in the projectile motion when we did, Pratik, got something?
No, sir. I'm just having some audio issue. It's going on unmute again and again.
Okay. So how do we approach this thing? See, if you remember in projectile, the main idea what we did, we split the motion into two directions, isn't it? So we will do the same thing here. So when you have the angle here, alpha, so we will choose the incline as your x-axis, and we will choose this part as your y-axis. See, you can choose x and y any direction you want, but only thing they should be perpendicular. And this you're projecting with u and theta. So this component would be u cos theta, which will be ux. This component will be uy, which is u sin theta. So we are resolving this into u cos theta and u sin theta. Now, the same way, I can even resolve the gravity into two pieces. So gravity is vertically down g. So this is the incline angle alpha. So we can resolve even g into two components: gravity along the incline, gravity perpendicular to incline. This also will be alpha. This would be g cos alpha. This would be g sine alpha. That means this gravity also can be split into two parts. So the gravity in the direction of x, you can remember this g sine alpha, g cos alpha. This would be g cos alpha. Basically, g cos alpha plays the role of ay, the vertical acceleration. G sine alpha plays the role of horizontal acceleration, ax. Now, if you turn the whole problem into a horizontal thing, this is what you will notice. If you make this whole thing flat, this is u and theta, you can clearly notice this is your u cos theta, which is ux. This is your u sine theta, which is uy. The gravity horizontally ax, which is g sine alpha, which looks like the wind problem in the last class. Ay is g cos alpha. So basically, this looks similar to the wind. And this guy looks similar to the gravity. So basically, g becomes g cos alpha. And the wind becomes g sine alpha. Are you getting the idea there? You can choose any axis as x and y. So I can split the acceleration also into two components and velocity also into two components. Have a look at this, how I divided this into components. So whenever inclines are given, choose the incline as x-axis, perpendicular to as y-axis. Then resolve the velocity components, resolve the acceleration components. Now you have your ax, ay, ux, uy. Let me show you how to do this in the next page. But any doubts on this resolution of components, please ask me. Clear, na? Taksha? Clear with this? Abhinav? Previous page. बस definition error और कुछ नहीं था. Now how do we solve this thing? See. So once we got the components here, what is time of flight? Time of flight is 2u vertical by a vertical. This is the reason I taught you this form. Because you can resolve any way you want. This formula is always valid. 2u vertical, a vertical. So what is 2u vertical? U vertical is u sine theta. A vertical is g cos alpha. Isn't it? So g ka place mein g cos alpha, u ka place mein u sine theta. And your equation sx uxt plus half axt square, the three equations are still valid. So here sx becomes range, ux becomes u cos theta. This becomes 2u sine theta, the time of flight, by g cos alpha ka square. And remember here, the acceleration is negative because it is opposite, minus I cap. We have taken the upward direction as plus I cap, so it is opposite. And this would be 2u sine theta by g cos alpha ka square. There, you can simplify that and you'll get an answer. Now, don't try to remember this thing. Understand how we are doing it. So, main thing is resolve the acceleration, resolve velocities, and you're done. You'll get your standard things. And here, Hmax does not make sense. Why? If you try to find Hmax, you know what you'll get? You'll get this height as Hmax, isn't it? That is of no use because when you're flying like this can be the Hmax, isn't it? So, in this case, in an incline, the Hmax formula is useless. Now, after getting this range, remember in a regular projectile, theta 45 gave maximum range. So here also I want to find what angle will give the maximum range. Then we have to do maximum minima. So for maximum range, so here alpha is constant, theta is variable. We have to do dr by d theta, the first differential equal to 0. We'll not be doing that. Let me show you what will be the answer. But have a look at this, how I did the final thing.
सर
हाँ रे,
इन रेंज का फर्स्ट पार्ट टाइम का स्क्वायर नहीं होगा.
नहीं होगा, sorry. Do you have a look at this? Clear? Now, when you do dr by d theta, we can differentiate this. So you will get something. So you will get the answer is this. So you get two cases actually. So you need to mug up these cases. Exam you won't have time to derive this. So for the maximum range on an incline, case 1, so when you throw it from the bottom, this is angle alpha. You're throwing like this with u and theta. The maximum range is u square by g into 1 plus sine alpha. And this occurs for an angle theta is equal to pi by 4 minus alpha by 2. It's not 45 degrees. It depends on that alpha also. Case 2, you're throwing from the top. In this case, you get maximum range is u square by g 1 minus sine alpha. And here the angle is pi by 4 plus alpha by 2. So the answer will change. So be careful with this. If I make alpha is equal to 0, what will happen? There is no incline. The incline will become flat. That means you'll get your 45 degrees back. हाँ प्रतीक, you can just remember that. Remember the process. ना ये सब रटा मारने का जरूरत नहीं है. Once you know how to divide the components, this तो you know, right? Bas, and this तो you know anyway. So just derive it from there. But these things you need to mug up. अभी इसको derive करने के लिए problem क्या होगा? You need to find range and then you have to differentiate this, right? Now that will become too long. If they just ask you range, it is fine. But maximum range, minimum range, maximum range in both the cases, you need to mug it up. So do write them down. We are going to use them later on. Note it down. Clear? Let's see a question. This is 30 degrees. This angle is also 30 degrees and you're projecting with 20 meters per second. Find range. Get ready, got 2-3 minutes. Straightforward. Component substitution done. In this case, theta alpha both are same. Everyone should give it a try. 80 by 3 here. This page. Previous one, then this thing. Daksh. Yep, right, Daksh. You got it. Ishana, Daksha. Yeah, most of you did get it. So, what to do? Resolve this into components. 20 meters per second. So this component would be ux, which is 20 cos 30, which is 10 root 3. 20 sine 30, which was 10. Gravity, you can directly remember this thing. Ax would be g sine alpha, that is 5. Ay would be g cos alpha. Mug it up, g cos alpha, g sine alpha. It will be helpful even in loss of motion next chapter. Hana, you goofed up. G cos alpha would be 10 5 root 3. So time of flight is 2u vertical by a vertical 2, 10, and a vertical is 5 root 3. That would be 4 by root 3. So range Sx will be ux time of flight plus half ax time of flight square. Ux is 10 root 3, time of flight is 4 by root 3, plus half, remember ax is minus 5 because it's in the opposite direction, time of flight square is 4 by root 3 ka square. This guy is 40 minus 5 by 2 into 16 by 3. 2's 8's 40 by 3, 80 by 3 meters. Yep. Easy, straightforward. Question hai tha. That's what I'm saying. If you know how to resolve the components, finish it off. So inclines are not actually really that scary now. So this and the wind problems have a similarity. Can I go ahead? Let's see one more.
So
This formula and the formula for max range give this. मतलब theta 30 degrees maximum range हो गया इस केस में. See, theta maximum range will come for what? Pi by 4 minus alpha by 2. So this is 45 minus 15 became 30 na. So you projected this angle with the maximum angle. Got my point? So luckily you got the answer. Every time you won't get that. इस केस में angle match हो गया था. Right, Arya? Someone was saying something? Same thing? Abhinav, you're saying something. हाँ.
Yes, sir. I was saying the same thing.
हाँ, इस केस में एंगल मैच हो गया है और कुछ नहीं है. नेक्स्ट केस में देखो मैच नहीं होगा.
Yes, sir. I got it. Thank you.
Yeah, 52. Let's say this is 37 degrees. You're projecting horizontally like this with 5 meters per second, and this is also 37 degrees. Now find range. Hope you remember sine 37 3 by 5, cos 37 4 by 5. You get it. Now once you know the technique, this is just brute force. Any answers? Try. We have one answer. Not sure whether it is right or wrong. Let's see. We have one answer. Anyone else got the same? We have 25 by 4. We have 3 by 4. We have 21 by 4. Shit, none of the three matching. Definitely two of you are wrong. We have two 3 by 4s. Interesting. We have 21 by 16. इतना variety answers आ रहे देख. We have two 21 by 16s. We have 23 by 4 also now. So far we have 25 by 4, 3 by 4. That was a weird one out of all. 21 by 16. 23 by 4. 75 by 16. Some reason I'm getting a feeling this is right. Gods, यहाँ पे AX will be positive. Hope you didn't goof up that part. Because here UX and AX both are in the same direction downward. So in this now, choose this as your x-axis. You're going down, right? And this is your UI. So this component would be UX, which is 5 cos 37. Cos 37 is 4 by 5, so 4. This UI is 5 sine 37. That is 3. So this gravity AX would be G sine alpha. G is 10 and sine 37 is 3 by 2. So this is 6. AY is G cos alpha. That is 8. Then the story is the sum of light is 2 UI by AY, which is 2, 3 by 8, so 3 by 4 seconds. I think the person who got 3 by 4, you wrote the time of flight. You didn't find the range, you found time of flight. That's why thinking that why was that answer 3 by 4 so weird? Now for range, what we do, we take UX, time of flight, plus half AX, time of flight square. So UX is 4, time of flight is 3 by 4. Now be careful here, it will be plus. Because see, I took this as I cap, isn't it? AX is also in the same direction. So when you're throwing from the top, AX will support. When you throw from the bottom, AX will oppose. So it will become a negative sign there. So you can choose. So if you say, no, sir, I still want to choose this as x-axis, fair enough. Then UX also will be negative. AY also will be negative. Are you getting it? UX, AX both will be negative then. So it doesn't matter actually. So half 6, 3 by 4 whole square. This is 3 plus 27 by 16. Am I right? 16 3 is 48. 48 plus 27. 75. Yeah, 75 by 16. Vihan, Ansh, Devansh, Nikhil. I think anyway, sab log got the answer at the same time. So what were you guys doing, Ray? You took minus AX minus kya? The guy who got 23 by 23 by 4, what did you do?
Sir, actually, I substituted GX as 8 instead of 6. और फिर
Oh,
3
ये
by
दोनों reverse
4
किया.
हाँ.
इसलिए सोच रहा हूँ इतना variety answers कैसा आ गया करके. Let's see, next one. All got this? Easy, right? So when you throw down, throw up, be careful that AX ka sign will be different. So we have an incline. This angle is alpha. This angle is alpha. When you project it from the bottom, angle is not given. R1 is the maximum range. That much we know. So angle to we can anyway figure out pi by 4 minus alpha by 2. when you project it from the top with the same speed, again here R2 is your maximum range. So when the particle is thrown from the bottom, the maximum range is R1. When it's thrown from the top, maximum range is R2. It is given R2 by R1 is equal to 3. Find alpha. Now, for people who don't know the result of maximum range, this is a horror problem. If you know the maximum range formula, this will look like a joke. So maximum range on an incline, you should know. The biggest confusion I used to get now is this only. U square by G, should I put 1 plus or minus sine alpha? Easy way to remember, think like this. When you're throwing from the top, the range should be more. The denominator should be small, so 1 minus sine alpha. When you're throwing from the top, the range should be small. The denominator should be more, so 1 plus sine alpha. I used to remember like that. I used to get confused between these two, 1 plus or sine alpha. Should I use minus or plus here? Let's get this easy one. This thing shouldn't take more than a minute. Yeah, right, Jainal. Two 225. God, क्या values आ रहे हैं boss? 30 रे आंसर. कहाँ से लेके आ रहे हो एंगल? 225 मतलब क्या कर रहे हो? तो सोचो ना लॉजिकली भी. 225 मतलब पता है इंक्लाइन कैसा है? ये 180 है. Then it is like this. क्या कर रहे हैं इंक्लाइन एग्जैक्टली? You guys know. So what is R2? R2 is U square by G1 minus sine alpha by R1 is U square by G1 plus sine alpha. This would be 1 plus sine alpha by 1 minus sine alpha. This is 3. We get sine alpha is equal to alpha is 30 degrees. Straightforward था भाई बोल रहा हूँ. If you know the maximum range का formulas, it's pretty easy question. But for people who don't remember the maximum range formula, you literally have to derive that formula and then use it. So it will become quite a lengthy question then. So you have to find range as function of theta and then theta ka differential and then we have to prove. Clear? And next one. Next one. We have an incline alpha. We projected a particle with theta. So this particle went up and it collided with the incline perpendicularly. Meaning when it is hitting the incline, it is hitting perpendicular to the incline. So find the condition or find the relation between theta and alpha if the particle collides with the incline perpendicularly. Collides perpendicular to the incline. Questions here? So when you're projecting, this thing hits the incline perpendicular to the surface. This happens for a particular relation between theta and alpha. Try. Just give it a try. I'll be back in a minute. Theta 45. Near. क्या आंसर था ये गॉड्स? 2 cos square alpha sin theta. पूर्व जो स्कोर सिंपलीफाई कर सकते हो तेरा आ गया आंसर देखो. हना यू जी नहीं रहा ना, जी एंड यू का टर्म्स में आएगा नहीं. लेट्स सी. things are weird. Niharika, you got it. See. U cos theta, U sin theta. This is ux, this is uy. This guy is ax, which is g sin alpha. This guy is ay, which is g cos alpha. So you are hitting the ground. So time of flight is 2uy by ay, which is 2u sin theta by g cos alpha. Okay, that is one. Now, when you're hitting the ground, look at the velocity. So this is Vy. At this instant, Vx is 0. Do you agree? If you're hitting the incline perpendicular to the surface, isn't your x component 0? How would just right? So we can write the equation Vx is equal to Ux plus Ax into t. So Vx is 0, Ux is u cos theta, Ax will be g sine alpha, and this will be your time of flight. So when the body lands on the ground at time of flight, the horizontal component becomes 0. So we get u cos theta is g sine alpha. Time of flight is 2u sine theta by cos alpha. U and g will cancel everywhere. So u and g आएगा नहीं आंसर में. Bring everything to one side, you'll get tan theta. Tan alpha 2 times is equal to 1. So tan theta, tan alpha is equal to R. So people who got that cos theta, sin theta and everything, if you simplify, you should get this. Now, Puruja, I think you will get it. वो दोनों cos square alpha नहीं आएगा रे, वो cos theta cos alpha था. You took that. Got this thing? Yeah. Right Niharika, you got that only. Cot को इस साइड लेके आ जाओ तो tan हो जाएगा ना. Have a look at this, everyone. Next one. Next one. Any doubts on this? Anyone who didn't get this, please ask me. You won't get 45. Don't be obsessed with that 45. Next thing. These all are okay questions. These are fine mains and bits level questions. How will they frame an advanced question on this? Use dot product. So we have two inclines. So this angle is 60 degree. This angle is 30 degree. You projected from here point A. You projected perpendicular to the surface. Huh? You projected perpendicular to this incline, and this guy went and landed on this incline also perpendicularly. You getting? You projected perpendicular to the surface, it goes and lands perpendicular to the surface. So this point, let's call it A, and let this point be B. Obviously, this angle is 90 between them. Gravity is also G. So a particle is projected from A perpendicular to the incline and lands at B perpendicular to the incline. So your landing and launching both are perpendicular to incline. The speed of projection is 10 root 3 meters per second. So the initial speed is given. So V is that final speed. So the question is find V, find time of flight, meaning the time taken to go from A to B. Now this height from here to here, let this height be HP. So the point B where it is landing is HP, and this height from here to here is HA. So HA and HB are the heights of A and B from the ground level. Find HA and HB. Is the question scenario clear, everyone? So there are two inclines, 30 and 60. Both are perpendicular to each other. Gravity is there as usual. You're launching with speed U perpendicular. You're landing on the incline perpendicular. You're launching with U and you're hitting with V. You know U ka value. Find V, find time of flight, find HA, HB. HA, HB are the heights of the 2 points from the ground level.
So,
हाँ God.
so in this case, if if there's a stone that's been thrown,
Mhm.
so will its path be circular? Is it like
Why
left side?
circular? Why circular?
So that's
Tell me
what I
one
was
thing. Like,
asking.
अरे God, when you throw something into the air, what did we prove? Trajectory क्या था? Trajectory क्या था? What was the trajectory? What is the shape of the trajectory? भूल गया क्या?
Okay, sir.
क्या था? What is the shape of this trajectory?
Parabolic. Okay.
So why does it matter from where to where do I throw from here to here? देखो, meaning, tell me one thing. If it is going like this, can't I find a position where, can't I draw a line like this, which is this perpendicular? Can't I draw another line where this is perpendicular? I can do that, right? So circle होने का क्या जरूरत था? It can be still a parabola. Remember that you throw something into the air, either you get a straight line or you get a parabola. दूसरा option नहीं है. Out of all, na, finding V is the easiest one in the question. Finding V is the easiest. Take a minute, then I'll show you the first part. If you ask me this advanced I'll ask you B and C. How do we proceed? See, the velocity part. Now, forget about incline and all those things, okay? But when you're projecting here with speed u perpendicular to the incline, this angle was 30. So this angle was 30, alternate angle. So this was 60. So when you went here and landed again perpendicular like this with V, this angle was 60. So this was 60 and this was 30. Now during a projectile motion, what remains constant? U cos theta is equal to V cos alpha. The horizontal velocity is always constant, isn't it? Whether you throw from incline, anything you do, it doesn't matter. The U is how much? U is 20 root 3. That is given, sorry, 10 root 3. Cos theta here is cos 60. V, I don't know. This is cos 30. 10 root 3 half V root 3 by 2. V is equal to 10 meters per second. Check. Purvaja, how can you get negative signs? God, height pucha tha.
Sir, I took the other side as positive, so it came as minus.
What did you find exactly? Heights?
No, sir, I found B only, but I took the other
No,
direction.
no. What did you, the answers you typed for which question?
B.
V, how can you get negative? नहीं ना. ठीक
No,
है,
sir,
देखो, maybe.
I considered the other option, the other direction positive.
ठीक है, चलेगा, still. नहीं, Daksha, that is not the answer. Your heights are not this thing. That is not the answer. HP नहीं है. Everyone got the speed? Speed was easy, right? Just horizontal component same था. अभी time of flight के लिए क्या करना था? Try. I'll give another minute or two. How do you find time of flight? Time is 2 seconds. Yeah, time is 2 seconds. Right, Puroja. Yeah, right, Daksha. See. Now listen carefully. Yeah? This is 90 degrees. Now what I will suggest, since you can choose x and y anyway, only thing they should be perpendicular. I will choose this direction as y-axis, and I will choose this direction as x-axis. I can choose anything as x and y, they should be perpendicular. Now from here, you are launching perpendicularly with u. Now see what is happening here. That means uy is u, ux is 0. Agreed? Initially, there is no horizontal component. Now when you go from here and land here, this is your Vx, whereas Vy is 0. You're getting it? So when you're launching, Ux is 0. When you're landing, Vy is 0. Is this making sense? So by choosing both the inclines as perpendicular, your life becomes easy. One is x and y, and you're hitting perpendicularly. So I can use the equation Vy is equal to Uy plus Ayt. Now be careful. We have to divide the component. So this is your Ax, which is g cos 30. So you're treating this incline, right? And this is your Ay, which is g sine 30. Okay, you can't use time of flight formula because it's not coming to the same level. Remember, time of flight formula is valid when you come back to the same level. So here you're not coming to the same x-axis. So Vy is becoming 0, Uy is 10 root 3, Ay is g sine 30. That's your time of flight. So 10 root 3 is equal to, I wrote wrong, no? I wrote wrong. ये g sine 30 था. This was g cos 30. That would be 5 root 3 time of flight. We get time of flight is equal to 2 seconds. Clear with this? Let's see behind. Next thing, if you got this, now look at this thing. This is your Sy, the vertical displacement. This is your Sx, the horizontal displacement. So I can use Sx is uxt plus half axt square. Ux is 0. Ax is g sine 30, that is 5, and time of flight square is 2 square. This is 10 meters. Sx is 10 meters. Sy is uyt plus half ayt square. This is 10 root 3, time is 2 seconds, plus ay is opposite, so minus 5 root 3 g cos 30 into 2 square. This thing turns out to be 15 root 3, no, 5 root 3. 20 root 3, 2 will cancel, 10 root 3. Clear with this? Now remember what I got is Sx and Sy. I didn't get what I want. So what you found was this. I'll turn the page. You found out this guy, Sy, which was 10 root 3, but I was asking you this one, HB, and this angle is 60. So HB is Sy sine 60, which was 10 root 3 into this 15 meters. Similarly, this was 30. This was Sx. I was asking you this thing HA. So HA is Sx sine 30. This was 10 meters, so this was 5. There, answer is 5 and 15. Getting it? What we found was the distances on the incline. What I want is the vertical heights. Please have a look at this. This is how you do this thing. So by treating the inclines as x and y axis, it becomes quite easy to solve because you know ux, uy, you know vx, vy. You can try to do in the ground frame, but yeah, it will go more complex if you try to do it normally, like you know, this is theta and that and all. Kar sakte ho. But it will not be this easy, like you know, which you got straightforward with equations. The biggest hint that you have to do this is this only. The angle 60 and 30, this is 90. That was the biggest hint telling you, boss, you can choose this as x and this is y. If this angle had been 30 and this had been 40, you would have been dead. It would be really messed up. You can still use the same logic and solve, but it won't be that easy. This won't be zero anymore. Do have a look at the steps.
So can you show the next page?
Hmm.
Thank you.
Clear? Great. That is how you do the incline things. Now, next thing, let's see a different variety of questions. I think my throat is gone today. Yeah, this thing now, when it rains and climate goes to things go bad. Let's see. 56. We have a wall here. An elastic wall. So you projected with a speed u and theta. So this ball goes, hits the wall, bounces back and falls on the ground. I'm sure you must have done this. So you go hit the wall here, you come back here. This distance is x. And the projection from here, d is the distance from here to the wall. R is your range, which is u square sine 2 theta by g. Now, what do you mean by this elastic wall? So the ball collides elastically with the wall and falls on the ground. So you need to find x. Now, what do you mean by elastic? So listen. So when you say elastic, the component perpendicular to the wall gets reversed. Let me show an example. And the component parallel to the wall remains unaffected. Meaning, think of like this. Suppose if you have a wall here, let's say a ball is coming like this, okay, 5 meters per second. And let's say this is some 10 meter per second. So this is before collision. So this component here, when it hits the wall, this component will reverse 5 meter per second. The speed will remain same. The vertical component is unaffected. So after collision, this is what will happen. So whichever speed that is perpendicular to the wall will get reversed, the other component will remain same. Easy question. Now the thing is, you have to think. The logic is little there, but once you get it, it gets over in a pretty fast. Yeah, right, Vihan Purvaja. I hope everyone got what you mean by elastic collision. Take a minute. Let's see. Yeah. So look at the idea here. So when you're projecting with u and theta, think of like this. If there was no wall, nothing, now you would have just gone and landed somewhere here, which was the range. Now, the moment you kept a wall here, think what you did. At this point, if you look at the velocity, we had u cos theta, the horizontal component, and the vertical component is vy. Isn't it? If there was no wall. Now, when you hit the wall, just now I told you, the horizontal component, this guy will become u cos theta. This guy will still remain same. So vertically, nothing will change. So this is what was supposed to happen. So whatever is supposed to happen on the other side, now that will happen on this side, like a mirror image, isn't it? Does it make sense? U cos theta, which is on the right side, will become left side. Means whatever is supposed to happen on the right will happen on the left side, like a mirror image. That means this distance was r minus d. So this distance also will be r minus d. Is this making sense? So whenever you have a wall, whatever is supposed to happen on the right, simply just reflect it. So after hitting the wall, the u cos theta reverses. The vertical didn't change. So whatever happens on the right will happen on the left now. U cos theta reverses and Vy remains same. Therefore, the path would be the mirror image about the wall. So the wall will act like a mirror. Whatever is happening on the right, uska reflection hoga. Therefore, we get x is equal to r minus t. Clear, everyone? Easy. There's no need to solve anything. एक बार logic आ गया तो. Let's see a version of this thing, little higher level. All clear? Going ahead. There are two walls. The distance between them is 3r by 13. Same thing, elastic walls. So from this corner, way you're projecting with u and theta. Find the point where the ball lands on the ground. So if you look at this, this will go hit, bounce, 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 bounce. That will start bouncing between the walls, isn't it? Find the point where ball lands on the ground. Find h max and time of flight. Neglect the time interval during collisions. So during colliding, there'll be a small negligible time, you can ignore it. Between A and B. वो क्या आंसर है गॉड? वी नो इट विल बी बिटवीन A and B only. Give me some value ना. ये देख. So tomorrow if you ask me a question and ask me sir what is the answer, I'll say it will be between A, B, C, D. नहीं गॉड, मिड पॉइंट नहीं है. Try. Now this and the previous one are related. What did I say just now? When you hit the wall, it becomes like a mirror. Now isn't this like two mirrors? Yeah, right. That is right. यहाँ पूर्वजा u cos theta कहाँ से लेके आया गॉड? हाँ है ना. हाँ है ना. दोनों वॉल्स का बीच का डिस्टेंस 3r पे 13 है. तुझे इससे बड़ा कहाँ से आ गया ना? सोचो. Time of flight, yeah, h max and time of flight will remain same, isn't it? That is a straightforward. Because when you collide with the walls, only the horizontal will reverse. Vertically, कुछ भी effect नहीं पड़ेगा. So time of flight and h max will remain same. That is the easiest one. Get the first part. वो छोड़ के सब कर रहे हो. Jainil, you're right. I got Arya. Just look at the answer you typed. You know what did you type? You said A is the answer. 3r by 13 from B. मतलब क्या? A is the answer. See, listen, everyone. The idea is the two walls which are there. What we are doing, we are simply folding the parabola. You have the full parabola. Break it into pieces, 3r by 13, 3r by 13, 3r by 13 pieces break karo, and each parabola simply fold it, right? Every time you collide, you're folding the parabola. So this is what we are doing there. This was the parabola. So I need to fit this parabola into this. I need to fold it. So A and B. So let's break this into pieces. So this is the first piece, 3r by 13. Second piece, third piece, fourth piece. 3r by 13, 3r by 13, 3r by 13, and the last piece will be r by 13, isn't it? Because total should be r. Any doubts on this part? Now, the first part.
Sir, how did you divide it into 4 parts? How did you know it would be only that many?
Fractions रे स्कूल में पढ़ा था अपना. You don't know how to divide 1 into fractions.
No, sir, but how did you get that each fragment would be 3r by 13?
What is the distance between the walls?
Yes.
So 3r by 13 pieces divide करना है because distance between the walls is 3r by 13. Or you thought 3 and 13 are lucky numbers. So अभी क्या करना था? So this is the first path. अच्छे से draw नहीं किया मैंने, but ठीक है. So see, this is the first piece. So that piece will be this now. Are you getting it? And this will be the first collision. So this will be the first collision on the right wall. Then after colliding, this piece will be there. Now see what will happen. It will reverse, isn't it? It will go like this. समझ में आ रहा है? Whenever you hit the wall, this piece will simply take a reflection. Na? Are you getting? Is that making sense, everyone? The reflection of it. So this will collide the point 2. You will collide at the left wall. Then you will come down like this. How do I draw this? Something like this. You will collide the third piece. I didn't draw that properly. That is also. Okay, I'm just drawing approximately. So somewhere here, that is not right, but okay. And then this is the fourth piece. Again, fourth you will collide with the thing here, the left wall. Third will be the right wall. And then the final piece you land on the ground. So this piece you will land on the ground. So from the left wall, you're at what distance? R by 13, isn't it? Is this making sense, everyone? So you simply take the parabola and you just keep fold it every 3r by 13, keep folding it. You're done. बस इतना ही करना था. Easy? Now it looks easy. And for the second part of the answer, right, the vertical components are unaffected during collision. Therefore, H max and time of flight remain same. Clear? Let me give you one more. You tell me the answer for this guy. Suppose the walls are there. This is a 2r by 17. Abhi बताओ, where will it land? Just approximately 2r by 13. Where will it land? Where will it land and how many collisions will happen with the wall? How many times the ball will collide with both the walls and where will it land? ये थोड़ा easy हो गया ना? रुको एक काम करते. 4r by 17. I changed it. 4r by 17. Get this fast. R by 38. तो अभी पैराबोला को 4R by 17 pieces कट करना है. Nere behind, that is wrong. So 4R by 17, 4R by 17, 4R by 17, 4R by 17. You'll be left with R by 17 last piece. Isn't it? So you will collide how many times? 1, 2, 3, 4. So 1, 2, 3, 4. Last may you land on the ground. R by 17 from left. Easy? Yeah, right, Vijay. Right, Ahana. I hope you're getting how to fold the parabolas. Now this you can take it to one more level. Will not do, but I'll just give an example. For example, listen. Suppose if you have a well like this. Okay. So it's an elastic well. All the walls are proper here. Now let's say the ball is coming like this, rolling with speed u. Okay. Now the question is this: find the condition if the ball comes out of the well. So one thing that can happen is the ball will come like this, will hit the edge here, getting it, and again will bounce and go back like this. Make sense? You can do that. Or the ball can hit here, can go off like this. Or the ball can hit here, 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 and here like this. Basically, if you look at this is nothing but that same parabola. If the well was not there, the ball would have gone like this now. If the well was not there, if it is just a floor, wouldn't the ball go like this? So now what you're doing, you're putting a cylinder here and you're folding the parabola. समझ में आ रहा है? Now we are folding parabolas inside the cylinder like this. Now, if you take a smaller cylinder, how are you folding the parabola? If you take a smaller cylinder like this, and cylinder like this, can you see? How did you get this path? This is the first piece, okay? This is the first piece till here. This is the second piece. And that's your third piece. दिख रहा है? You can fold this parabola not only with a line, you can fold it even inside a cylinder. Is this logic making sense? Now, you tell me how will you fold this parabola? Let's say we have a cylinder here. The ball is coming like this, and this angle is 60 degrees. Matlab, top view is this. You're sending the ball like this at angle 60 degrees. You're getting the ball is falling into the well, not straight along the diameter, but at an angle. Can you tell me how will this look? Did you get what I'm asking? The ball is coming from the top. In this question, right, the ball was coming along the diameter, right, straight towards the center. But here the ball is coming at an angle. It will not go towards the center. How do you think the path will look? Now, if you see from the top view, this will go and hit somewhere here. I'll show you the side view. If this is 60, wait, I gave wrong actually. Chalega 60 le sakte. If you take this is 60, this is 60, this is 60, this is 60. If this is 60, how many pieces you'll get like this total? 360, right? That means you'll get 5 pieces. It will collide here. 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 You'll get a pentagon. That means the side view, you have to fold the parabola like a pentagon 5 times inside. Meaning you start from here. It's difficult to draw this way. and it will collide somewhere here, then it will collide somewhere here, here, something like this. I'm not getting how to draw this. You're getting this side view. Let me take a simpler example. Think about this thing. Later on we will see this some other time in collisions. Let's say this angle is 30 degrees. This would be a little better. So if you look at the top view, if this is 30, this is 30, so this is 30, so this is 120. So it will form just an equilateral triangle. You're getting how will the motion go? This is the top view. Huh? If you see from the top, you think it is going in a line, whereas in reality, the ball is also falling inside. The motion would look something like this. The ball from here is landing here, hits, then it hits, and then something like it's a 3D thing. It hits somewhere here. And then I wrote it only wrong. It hits somewhere here. Drawing in 3D is difficult, right? Somewhere like this, it goes off like this. ऐसा कुछ होगा. Are you getting right? How it will fold in 3D? I'm unable to draw that. But if you see from the top, it looks like a triangle. But actually, this is a parabola which is going down. समझ में आया? So I can play like that. I can keep changing angles. I can get different shapes. So you can fold the parabola and cylinders also. But anyway, but this much is clear. So you can fold like this. Abhinav, bolo now.
Sir, can you go to the highest, that 60 degrees slide? Sir, in this one, it would make 6. So it would be hexagon.
No, sorry, hexagon though. Yeah, hexagon though. Still a dot pentagon, no? Shit, right. I took the angle too much, I guess. Something like this, yeah. It's a hexagon. My mistake, 60. Clear with this? So there, with that, we're done with the projectile motion part. Right, we'll wrap up early today. I'm not keeping well. So next class, when we catch up, we'll continue from this thing. We'll start off with relative motion. Quite an important one. Relative motion, especially the relative motion in 2D is important. There we have some pretty nice problems. Cat is chasing, dog is chasing cat and all those stuff, and triangles rotating. We have more weird ones. That is the most important one. After that, we have Rainman and riverboat problems. Those are actually a little easy ones. But relative motion is quite big. I think it will go for almost 2 to 3 classes. And then after that, we'll do graphs. So mostly another 2.5 weeks, we should wrap up the chapter. So okay, with that, we'll wrap up for the day. So we have done almost 57 questions. I think we will touch almost 80. So do make sure to resolve all these 57 questions, right? And there is a test online till tonight. I hope you have given. If you have not given, the deadline is till 11. Make sure